So no one is more eagerly anticipating the next version of Instant JChem than we are at GSK. We are deploying it on an enterprise scale, that is, to a large number of users. We've, over the past couple of years, been working with ChemAxon to simplify our chemistry landscape, replacing our web services, our cartridge functionality, a lot of our desktop applications. And in this, our latest endeavor is perhaps our most challenging one yet. That is to replace ISIS with Instant JChem. So the challenge in front of us. We've got a product that's been with us for quite some time that has 400 projects that are out there. And we had 12 months to deliver those 400 projects into Instant JChem projects. These projects are scattered across about 2,500 users in multiple countries, and they draw data from about 15 to 20,000 database tables and views. So it's a daunting task. There's quite a bit of work to do to migrate those projects over to Instant JChem. We also had to take into account multiple security models in order to allow some people to access certain projects, other special groups only access to specific projects, and then some super user and administrative roles. And we wanted to also find a place to put all of these projects so that we could go through the list, sort them, find the one that's most interesting to the scientist, and basically find that single home for all the projects, rather than having them connect in through IJC and then try to navigate a database. And finally, perhaps the most daunting task is to do all that and deliver at the same search performance that we had before, or even better, if we can manage it. So the first step, tackling the problem, the scale. And the first question we asked ourselves was, all right, do we really need all 400 projects? So after a little bit of analysis, we took a look at the usage patterns over about a year period and found that there was a tail off after about 200 projects. After that, you only had a smattering of use. We figured, well, we'll draw the line at about that 200 mark and take the rest of those, migrate those or archive those, and migrate the 200 projects. So that split the problem in half. Still a daunting problem because each one of these migrations, when done by hand, takes about 3 days. You got to take all the form sources and you got to move them over to a different location. You got to make the form layout look the same way. It was a 3-day task for each one of those, and that's when it worked out well. So we had to find a way to streamline that, and our answer was to automate at every opportunity. To that end, we got a little bit lucky. ISIS and applications of that vintage oftentimes have files that are used, oftentimes the files that are used to configure them are binary. In ISIS's case, it was text-readable, human-readable files that we could then parse and automate and do some work on. So this was a lucky break for us. So essentially you have two types, or two files that you're dealing with. One is the data hierarchy, that is the data sources, the relationships between the parent and child, and where the databases are. All that's defined in this HBD file, the data hierarchy file. And so our first step was to write a script to get those views into Oracle. Oracle is something IJC understands quite well. Get them into Oracle, and then we can start having IJC consume them. Well, you still have to get it. IJC can, of course, recognize those, but you still have to get it to where they are promoted within IJC to be useful objects that you could then put on a form. So we have a Java application with a lot of assistance from the ChemAxon folks using the Discovery Informatics framework to populate those items into the data trees and entities that would be useful for a form. So the next step is, right, we've got the data set, we have the tree, but we needed to have the form. Well, fortunately, we could extract the FRM files, that is the things that defines the tables and widgets on an ISIS form. And again, using a Java application in the Discovery Informatics framework, we're able to put those into IJC form widgets, approximately the same. So these are essentially the same steps. We have custom scripts and Java applications to do each one of these steps. And in the end, we have widgets on a form. However, it's not as pretty as all that. Each one of these steps involved a little bit of hand-holding because the scripts weren't perfect, and when you're done, you end up with the widgets on the form, but not laid out the same way that they would be in ISIS. So they're basically clustered all in one place. So you still have to do a little bit of craft work to lay those out. One feature of IJC 5.5 that really helped us out with this was the ability to cut and paste these widgets and move them around. This sounds like a simple thing, but imagine if you have a structure, two fields like a text field and an integer field, or even a full form that looks really nice, and you decide you want to put it in a tab. In older versions, you would have actually had to create every one of those things in the tab. You would have had to drag the form objects onto the page, lay them out again. But in IJC 5.5, you could simply cut all the items, create a tab, drop or paste all of those onto the new form. Very, very nice, very useful stuff. So as a result of all this automation and the improvements in 5.5, we were able to cut that 2 to 3 days down to about 1 day, and that's an average. We actually had a lot that were much faster than that. Just the more complex ones sometimes pushed it over. This made it a task that we could actually sink our teeth into. Next thing we needed to do was tackle the different security models that we would need to support. And the most typical one, the one that was the most common, was that scientists as a group, and that's just anyone with this so-called secure access to view discovery data, would be able to see almost all the projects out there. And that's this group here. They'd be able to see most of the projects as long as they were part of this large LDAP group. However, when you're working with Alliance information, sometimes you need to secure certain projects. And you want that secured to a specific team, again, controlled by a certain LDAP group. But then you might have a role in which you want elevated privileges to create new projects, or remove projects, or edit the ones that are in there. Well, that's the role that would be satisfied by this project owners group. So they would have edit privileges, enhanced privileges to make changes to the projects that are out there. We needed a security mechanism that allowed us to support all of those types. So security breaks down into authentication and authorization. Authentication, essentially, I am who I say I am. And authorization, do I have the privilege to do something that's associated with my role? And we've already identified 3 different scenarios that we needed. And I have to say that ChemAxon definitely delivered that in 5.5. They put some security configuration options in 5.5 that allowed us to satisfy all of those. It was very well received. One caveat, we find that IJC security applies to the project, but does not apply to the forms contained in the project. So for example, a project is the data tree and the collection of views on that data tree, as well as other things like scripts and that sort of thing. The security mechanism does not allow you to control the views that are already in there. So for example, if a user creates a view and then shares it to the world and then leaves the company, you cannot change, at least not with the, within the IJC interface, you can't change the owner of that view. So there are a few things that beg for enhancement, but that's just my plea. I think that it's a good security mechanism all in all, but I think that the next step would be to take it to the form level. Next problem was we started to collect a lot of these projects. As we were inching up towards the 200, we had to find a way to very easily get it to the desktop and very easily manage that list. This is where we took advantage of the JChem URLs. JChem URLs allow us to use Java Web Start to launch the application, as well as launch it to a specific project. This was extremely useful, as it allowed us to take away all of the all of the complexity of a user having to put in a JDBC connection string in order to get to the database and see all the projects that are out there. We wanted to avoid that. We wanted to have it to where they could just see their project, click the link, launch the application, and see their project. This allowed us to do that. However, now we've got 200 of these project URLs, which actually don't mean much in and of themselves. So we went ahead and took those and put them into Microsoft SharePoint. SharePoint gives us the advantage of working well with lists. So we could apply a number of columns of information to the URLs. So for example, the project name, the project owner, the status, the modification date, and allow those to be seen in a tabular format and manipulated quite easily by the scientific community. Allows a person to go into the site, see all the projects that are available to them, and simply click and launch the project they want. There are some disadvantages to that, little caveats that we found out with SharePoint that surprised us. SharePoint limits the URLs to 255 characters. An IJC connection string or an IJC URL can be quite long if you choose a long project name, and it can go beyond that 255, which we found out to our chagrin. But so just be aware of that. The other thing is that building those URLs is not a straightforward task for most users. You have to essentially create a number of files, put them on a server somewhere, and then generate a URL. It's something that could probably be made a bit easier through the UI. So right now we have that as support-driven tasks. So when it comes to the next phase, which was performance, we had a number of architectural considerations. I'll put that in a polite context. GSK had some constraints that we knew would make this more interesting or more challenging. One was that our chemical and biological data were hosted in one UK site. Of course, that means that IJC performed fantastically at the UK site. Not so much for US, definitely not for China. The next point that we had was the fact that the databases, that is the chemical structure database and the biological database, are not in the same Oracle instance. So we had to find ways to join that information onto the same form in a particular IJC project. And finally, a little bit of clutter that we had was the fact that these ISIS projects were being fed by thousands of tables. So we had to create thousands of views. From the IJC side, there was the problem of not being able to join across Oracle schema instances in order to put structural and biological data in our situation in the same place. You are tied to wherever the JChem cartridge is. If you're using a cartridge, that's where your data are going to be coming from. So, but that can be solved. I mean, this was something we were able to come up with workarounds for, but it was seen as somewhat of a limitation. The other point was that the search results, when you went to go bring back your search results, we were hoping for the results to be coming back in batch mode rather than in record by record. So if I'm navigating and quickly clicking through a list of search results, we wouldn't want it to go across the pond to get that next result. We'd like it to get, say, the next 10. So the problems we had to solve, it boiled down to these two pieces. We realized that we needed the co-location of the data, that is the chemical and biological data, in order to feed a single IJC form. And we had to resolve the problems due to latency. So because it's a pretty chatty connection, every time you take that hit, you're impacted by the toll of latency. So some of the possible remedies. Simulate that co-location of source databases. So in our case, we use database links. So in the chemical database, we actually created database links over to the biological database and thus made it appear local. This actually worked fairly well. The other option is to host them under a virtual setting using something like Composite or some virtual solution. We did try this option out as well, but we were probably a little far along in the project to really go full-blown with that, although I do recommend it as a solution worth trying. You want to get your data into one physical or virtual single location before throwing a MyJC on top of it. And then when it came to solutions for latency, it's pretty simple. You either reduce the number of queries, that is, reduce the number of times you pay the toll to cross the bridge, or you don't cross the bridge. You reduce the geographical distance. We actually struck a balance there. We tried to optimize where possible, and we got to the point where we actually put all of the IJC projects behind Citrix. So essentially, it's still in UK. You've still got the projects all connected very closely to their databases, but you're going over the pipe and allowing the chattiness to happen on that side. So just some musings. I don't think that any of this completely conflicts with some of the stuff that Tim pointed out. I'm actually quite excited about some of the architectural directions that they're taking. Just more curiosity as to where we're going next, whether Instant JChem has a more future as a thick client or a thin client, or maybe both. There are benefits and drawbacks to each, as articulated here. This JChem server, we're curious as to, there's definitely need for a middle tier, what all will be done in that middle tier. I listened with a lot of interest as he presented the architecture of that middle tier, and I look forward to seeing it. Is it going to be a place that actually hosts up the entire view? Is it going to be a place for just form security? Is it going to be a place that actually does the data consolidation? Who knows? I'm intrigued. And then I've actually separated out from the JChem server this data virtualization layer or server or source. I think there are a lot of products out there that can do that work. I think that it's probably something that ChemAxon could probably leverage those solutions and then take their expertise in and have it put that into their JChem server. But that's my personal thoughts on that. Finally, I want to acknowledge the team members who've been working on this. I especially want to call out to Daniel and Attila, who've been working very hard to migrate these projects. They are talented ChemAxon people. Tim's been very, very responsive to our calls and our pleas, and some of the other people on the IJC team, Peter and Masood, have been very responsive to our questions. And thank you very much for your time.
Thank you.